also be taught in the English language. So the topic or the theme of this degree is high performance computing, HPC, and quantum computing. As you can see in this picture, what does it actually mean, right? Quantum computing, you've heard it, I'm sure, a lot recently, but it's not just a buzzword. Quantum computing is actually the next evolutionary step in computer science. And it's not that far out, to be honest. So if you looked at the news, at the past news, companies like Google and IBM have already summarized or already shown us that we can achieve the quantum supremacy. So basically, there is clear data then that in some respects, quantum computing can be and is actually faster and useful in some fields. So I've put here on this slide just a few of them. So climate research, cryptography, and pharmacology are the typical fields, are the low-hanging fruits for the next decade to look into when we are talking quantum computing. But quantum computing is a field that is new and young and being built. You have to remember that in the next decade, or potentially a bit longer, you will need a second technology as well. You will also need skills in HPC, and that is high performance computing, right? So I myself have a strong background in HPC, coming from the industry, as many of my colleagues do as well, right? So here we will be able to support you with the knowledge, with the network, to actually become experts in those two particular areas. So what does our course actually mean? By the end of the 3 semesters, which are about 1.5 years, you will receive, if and when you're successful, a master's degree in science. The start of this particular degree is in October. And I have to tell you, this will be the first semester, the first one with this particular topic. So this is brand new. My university, and actually this is my alma mater, so I came back as a professor. This should tell you how awesome it is. This university is also one of the most innovative ones. So what we're trying to do is always to look into the future. What technologies are on the horizon? How is the science developing? What is the requirement from the industry? Where is all of this going, right? And according to those requirements, we are developing the courses. And as you can see here, one of them will be quantum computing starting this fall. As I also told you, the language in which we will be teaching is English. So that should also be helpful, particularly to international students. What are the requirements? And I have to tell you, the most important one is actually the thirst for knowledge and curiosity, right? You have to be curious and agile in your mind. And this is, again, not just a buzzword, but a real requirement. If you look at the traditional computing you have right now, you're usually working with the zeros and ones, right? So this is conventional, traditional digital computing. If you look at quantum computing, you are working in quantum dots. Like you don't have the heads and tails, but you can have heads and tails simultaneously, or a combination of those. So the thinking is different from what you used to have in the traditional computing. So you have to be agile in your mind, to actually be able to think differently, think outside the box. Also, which is very important, is not just the programming in such, but also to be able to imagine what could be possibly done using this brand new technology, right? What are the application fields? Where can this be useful? With quantum computing, you basically have a new shiny tool, a new hammer in your hand. And now you are on the track to go and find the nails you can use the hammer for, right? You have to find the problems. And for that, you need a specific set of mind, the curiosity to go out and look for problems you can solve. Again, with this course, the language requirement is B2, but we have a very, very good support in this field. So if you have any questions, I'm sure you can look at our website, and there's a whole department that will support you with responding to your questions. Good news again for you, there will be no tuition fees. We are state funded. So the only fee you will have to pay if you join our university is the 62 euros student service per semester. General information is attached. I'm sure our host will be sharing those links later in the presentation. So what can you do with this degree? Also probably quite interesting for you. You can do a whole lot. So by the end of this 1.5 semesters, you will receive a whole set of different skills, and we will look at them in the next slide. So when you receive those skills, you will be able to do a whole series of different things, starting from looking at the infrastructure, right? To build a new HPC system, like a very huge machine, you need to look into infrastructure, into housing, to be able to actually build the system and house the system, and to administrate the system. And you will receive the skills here. That goes for HPC and quantum computing as well. You will be able to actually apply your skills in programming, in software design. Again, the classical HPC environment is quite different from the new upcoming quantum computing environment. So you will have the tools to actually be able to work both. But this is not all. You will also receive additional skills in economics, for example. So what you will be able to do is apply your knowledge in technology and actually design new products, design new services. And for that, you obviously need some economics knowledge. And this is, again, a very lucrative field to look forward to. So innovation management is also on this slide. We have at this university a startup campus, which is not new. We've been doing it for a number of years now. Basically, the students who are starting their work here, the education in here, will also be able to apply their knowledge in becoming self-reliant, in building their ideas into products. And the university is supporting you with that as well. So the innovation management is not just a course. You can actually apply your knowledge and use your knowledge in developing your new shiny thing. Let's look at the modules. There are basically 4 of them. So there is, if you look at the 3 semesters, there is this hardware design and energy efficiency. If you look at HPC, energy cost is amazing. So the average energy cost in a data center is about 50% of the overall cost, right? This is huge. So we will teach you to look and optimize the energy cost. Software design and performance optimization. This is where the power comes from, right? So the computing power and how to utilize it. Here you will learn that. So this is advanced mathematics, applied mathematics, optimization methodology and methods. This is the second part. And the third part is system design administration. So here you will actually learn how to design the machine and how to use it, how to utilize it. The fourth module is below, at the bottom, and this is the interdisciplinary content. So here is basically the economics, the engineering, and all the electives that go into. Okay. So here is again just split up the same content. The module content, so basically the programming and the design of the of that top part is split in the first part. Then you have the second one focusing on quantum, basically the quantum mechanics, hardware platforms, and those things. And the electives and the general things, which is infrastructure and things like that. So this is basically it. I'm looking for your questions. Just on my last comment, if you look into studying HPC and quantum computing, you have to be aware that when you're done, you will be counting as one of the very few in the whole world. This master's program is the first in all of Germany focusing on quantum computing, not providing just 1 or 2 courses, but a full master's program. And this goes for worldwide as well. There are not that many who are offering this new and amazingly interesting field for study. So when you're done in 1.5 years, you will be one of the very few out there that are actually able to design the systems, work them, and be on the forefront of technology. Thank you very much.